International System of Numeration. In the International System of Numeration, as it is being used, we have ones, tens, hundreds, thousands, and then millions. 1,000,000 is 1,000 thousands. Commas are used to mark thousands and millions. It comes after every 3 digits from the right. Now the first comma marks thousands and the next comma marks millions. Let me give you an example. 50, 801, 592 is read as 50,801,592 in the international system, and in the Indian system it is read as correct 5,08,01,592. To express numbers larger than million, a billion is used in International System of Numeration. Large numbers in practice. Earlier we have learned that we use centimeters as unit of length for measuring small length such as book, pencil, etc. To measure small width such as pencil, we use millimeters. And to measure length of a classroom, we can use meter, as millimeter and centimeters are too small for it. You know what, kids? Even meter is too small to measure distance between the cities. For that, we need kilometers. We can write 1 centimeter is equal to 10 millimeters. 1 meter is equal to 100 centimeters. Now that is equal to 1000 millimeters. 1 kilometer is equal to 1000 meters, which is further equal to 1 lakh centimeters, which is further equal to 10 lakh millimeters. Similarly, we have 1 gram is equal to 1000 milligrams, 1 kilogram is equal to 1000 grams, 1 liter is equal to 1000 milliliters. And these are commonly used units in our day-to-day life. Estimation. News. Approximately 20,000 people were killed and more than 50,000 injured in a cyclonic storm in coastal areas of Bangladesh. Number 2. India drew with Pakistan in a cricket match watched by 51,000 spectators in stadium and 40 million television viewers worldwide. Can we say that there were exactly as many people as the number quoted in these news? In second example, were there exactly 51,000 spectators in the stadium? Or did exactly 40 million viewers watch the match on television? Obviously not. The word approximately itself indicates that the number of people were near about these numbers. Clearly 51,000 could be 50,800 or 51,300, but not 70,000. Similarly, 40 million implies much more than 39 million, but quite less than 41 million, but certainly not 50 million. Estimating to the nearest tens by rounding off. Let us consider number 12, which lies between 10 and 20. However, 12 is closer to 10 than 20. So, we round off 12 to 10, correct to the nearest 10. Now consider number 17. Here again 17 lies between 10 and 20. But 17 is closer to 20 than 10. So we round off 17 to 20. That is to the nearest 10. Similarly, we can round off hundreds and thousands. There are no rigid rules when you want to estimate the outcomes of numbers. The procedure depends upon the degree of accuracy required and how quickly the estimate is needed. The most important thing is how sensible the guessed answer would be. To estimate sum or difference, we often see that the trader rounded off the amounts to nearest thousands. Hey kids, let me explain you with an example. 5673 minus 436. To get the proper estimate, let us try rounding each number to 100. So, 5673 rounds off to 5700 and 436 rounds off to 400. So the estimated difference would be 5300 or 5300. Now this is a meaningful estimate. Alright? Kids, we can also estimate a product. For that, let us see an example. 19 multiplied by 78. First, let us approximate 19 to nearest tens. So it would be 20. And the approximate of 78 to nearest tens would be 80. So it would be 20 into 80, which is equal to 1600. Using brackets. Why is it necessary to use brackets in calculation? Well kids, in order to get the answer, let us see one example. Teacher asked in a class if Sita bought 6 notebooks from shop and the cost was rupees 10 per notebook. Her sister Geeta bought 7 notebooks of the same type. Find the total money spent. Now Seema calculated as 6 into 10 plus 7 into 10. That would be equal to 60 plus 70, which is equal to 130. Therefore, the answer is rupees 130. Now, Meera calculated as 6 plus 7 is equal to 13 and 13 into 10 is equal to 130. So, the answer is rupees 130. Whereas, Appu calculated as 7 plus 6 into 10. Now this is equal to 7 plus 60, which is equal to 67. Though Seema and Meera got the same answer, but Appu got another answer. Well, students will definitely get confused. So, the teacher told the students to avoid such confusion, we must use brackets. So, bracket open, 6 into 7 bracket close, multiply by 10 is equal to 13 into 10, which is equal to 130. So the answer is 130. This clearly tells us first turn everything inside the brackets into single number and then do the operation outside, which in this case is to multiply by 10. Expanding brackets. Now, observe that how the use of brackets allow us to follow our procedure systematically. I'll give you an example. 17 into 109. Well, we can write it as bracket open 10 plus 7 bracket close into 109. Now this is equal to 10 into 109 plus 7 into 109. Now further we can write it as 10 into bracket open 100 plus 9 bracket close plus 7 into bracket open 100 plus 9 bracket close. Now this is equal to 10 into 100 plus 10 into 9 plus 7 into 100 plus 7 into 9. This is equal to 1000 plus 90 plus 700 plus 63. This is further equal to 1790 plus 63, which is equal to 1853, and we have our answer. Roman numerals. Hey kids, we have been using Hindu-Arabic system so far. But this is not the only system available. One of the early systems of writing numerals is the system of Roman numerals. This system is still used in many places. Well, have you noticed wall clocks? Some of the wall clocks have X, V, things written on it. They have Roman numerals, sometimes even your school timetables. Now 1 to 10 can be written in Roman numerals as I, double I, triple I, IV, V, VI, V double I, V triple I, IX, and X. This is followed by XI, that is for 11, and X double I, which is for 12, and so on. Some more Roman numerals are I is for 1, V is for 5, X is for 10, L is for 50, C is for 100, D is for 500, and M is for 1000. The rules for the system are: number 1. If a symbol is repeated, its value is added as many times as it occurs. Well, that is, double I is equal to 2. Double X is equal to, correct, 20. How about triple X? You're right again, it is 30. Number 2. A symbol is not repeated more than 3 times. But there are symbols like V, L, T, they are never repeated. Number 3. If a symbol of smaller value is written to the right of a symbol of greater value, its value gets added to the value of greater symbol. Don't worry, I'll explain you with an example. VI. Now VI would be 5 plus 1, that is 6. Tell me about LXV. Yes, my genius, it is 50 plus 10 plus 5, that is 65. Number 4. If a symbol of smaller value is written to the left of a symbol of greater value, its value is subtracted from the value of greater symbol. Here again we'll use some examples. IV. IV is 5 minus 1, that is 4. IX. IX is 10 minus 1, that is 9. XL. XL is 50 minus 10, that is 40. Tell me about XC. Correct. 100 minus 10, that is 90. Number 5. The symbols V, L, and D are never written to the left of symbol of greater value. You know what it means? It means V, L, and D are never subtracted. The symbol I can be subtracted from V and X only. The symbol X can be subtracted from L, M, and C only. Thus, following all these rules, we get I for 1, double I for 2, triple I for 3, IV for 4, V for 5, VI for 6, V double I for 7, V triple I for 8, IX for 9, X for 10, double X for 20, triple X for 30, XL for 40, L for 50, LX for 60, LXX for 70, LXXX for 80, XC for 90. C is for 100,